Hello everyone, we have a few questions from a mock test of maths today, and this first question I thought I really need to discuss. So these are all the questions that we are going to be solving today. It might be a little long. Feel free to pause and try the questions, and definitely this first question is very good. So let's just start and try to do it ASAP, right? Okay, so fx is this function. I'll just take this common. Okay, so I have the curve fx has two distinct critical points and b is the constant number satisfying. Okay, let's just look at the inequality first. Okay, so b plus 1 is greater than 2b squared, and this would give me b belongs to minus 1 by 2 to 1. Okay, okay, now when I try to find the critical points for fx, I would find that f dash x is 5a times x minus 1 power 4 plus 4b x minus 1 power 3. So clearly x is equal to 1 is a solution here, and I would get 5a x minus 5a plus 4b is equal to 0. That means x is equal to 4b, sorry, 5, or I can say 1 minus 4b by 5a. So it's been given that these are distinct critical points. So d cannot be 0. That's why we have limit b tending 0 in the question. Alright, and okay, let's move forward. So I have two parts. Now, as b is limiting 0, I need two cases as b belongs to minus 1 by 2 to 1. Okay, so let's just break it into two cases. Alright, case 1. Case 1 is b is less than 0, b belongs to minus 1 by 2 to 0. So the statement says limit b tending 0 5 times f max minus b square upon sine power 5b. One second, let me just check. No, it's b power 5. Alright, yeah, and minus 2 power 5 mod b upon 25 a squared sine b. Also, I would like to give credits to Abhishek Gupta sir for this question. I took it from the YouTube channel. You can check them out. I'll make sure to link them in the description. Okay, so this is the quantity that we have been told that it exists and it equals to L. Okay, and L is being used in the fourth part of this question. Okay, so I'm gonna be taking b is less than 0, so this would become this, and this is the limit b tending 0. Now what about f max? So for f max, I got that fx was a x minus 1 power 5 plus b x minus 1 power 4. So f of 1 is 0, and f of 1 minus 4b by 5a would be 4b by 5a. uh, okay, when you calculate this, you would get 4 by a power 4 times b by 5 power 5. Now this is a positive quantity, right? And this is a negative quantity, so this would be less than 0, right? So I can say that the other critical point gives me a minimum value and this is the maximum value. So I can say that f max is equal to 0 in this case, right? Okay, so I would get limit b tending 0 minus b power 5 by sine power 5b plus 2 power 5. I had b also here. Yeah, b just changed to minus b, right? And upon 25 a squared sine b. So this is 1, and Obviously this is 1. So minus 1 plus 2 power 5 by 25 a square. Yes. So this is my first. So this is L. Okay. Now I'm gonna just use the same thing that I've just done yet, and I would find another value of L, right? Also, I did not take a is equal to 0 as a case because a is in the denominator of 1 minus 4b by 5a, and this critical point would just not have existed, right? So a is not 0. Okay. Now let's go to case 2. B was from minus 1 by 2 to 1. So now we have 0 to 1. Okay. So B is greater than equal to 0, and I would get fx. So again, I had f of 1 is equal to 0 and f of 1 minus 4b by 5a to be 4 by a power 4 and b by 5 power 5. Now this time it's positive, so this is a positive quantity greater than 0, so f max is this quantity, whatever it is, right? So I would have limit b tending 0, 5 f max minus minus b powered 5. Let me just check. Yeah. So minus b powered 5 by sine power 5b minus 2 power 5b. Yeah, this would be positive b, and 25 a squared sine b. Obviously, I can just make this 1, and for this, yeah. So for this, I would have f max to be this quantity. So 5 times 4 by a power 4 b by 5 power 5 minus b power 5. Yeah, I think pretty much everything is fine here. So b power 5 and sine power 5b, all of it is gone from the equation, and I am left with 5 times 4 by a power 4 by 5 power 5. So this would be 4 by 5a power 4, and yeah, minus 1, and yeah, and I just took b power 5 common, and by sine power 5b, which got cancelled, minus 2 by 5 power 25 a square. So this is my final value for this. I hope it's fine. Yeah. So this is another value for L. Now I have two equations, both are values of L. I would equate them, right? So my first value gave me 2 power 5 by 25 a squared minus 1, and the other one is 4 power 4 by 5a power 4 by 5a power 4 minus 1 minus 2 power 5 by 25 a squared. This should be 2 power 6 by 25 a squared is equal to 4 by 5a power 4. I hope my calculation is fine. Yeah. So when you solve this, you would get a square is equal to 4 by 25, and yeah, you can find the value of a, which is not trivial here. Okay. So now we have the value of a square. Now I want to go on, and yeah, I'll just put this value in and find L, and then we can proceed to just start solving the actual question. Okay. So L was 2 power 5 by 25 a squared minus 1. This would be 2 power 5 by 25 4 by 25. So this would be 7, right? Minus 1. This is 8, and yeah, this is 7. So L is equal to 7 for our question. Now let's come back to the questions. Okay. Um. Wait. 1 second. Wrong question. This one. Just get a copy of this question. Yeah. So let's come back to our cases now. Sorry, to the parts of the question. So the first part asks me that u and v are integers, then the number of possible ordered pairs uv which will satisfy the equation. Okay, v plus 1 times u minus 2 is equal to 7, right? So obviously I can say that v plus 1 and u minus 2 also belong to integer, and writing, so for each v plus 1 I would have a v, and for each u minus 2 I would have a u. So I just need to find the values of this. Any a b is equal to 7 such that a and b belong to integers. Positive or negative, both works. So I can just have 1 7 minus 1 minus 7, yeah, and then I can just uh, take it two times, because a can be 7, b can be 1, and a can be minus 7, b can be minus 1. So the total number of pairs would be 4. I hope that's right. I think that is right. I don't have the actual answer p. Okay, next question. Next question is a really good part. It uses AOD, so that is a good concept question. So if a is equal to b, then number of possible solution of the equation fx is equal to log power 5 x. Okay, so let's move forward. So I have, so my fx was a times x minus 1 power 5 plus b times x minus 1 power 4. So I would take x minus 1 power 4 and x minus a plus a, right? So this would be ax times x minus 1 power 4, and such that a was plus minus 2 by 5. So I have two values of a for this question, and if I draw the graph for this, right, I need to draw the graph. I would have 0 and I would have 1. Now looking at numbers greater than 1, this is going to tend to infinity, right? And before a 1 greater than 0, it's gonna reach a point, and then it would go to negative infinity. And if I just take minus 2 by 5, this is the case for plus 2 by 5. A is equal to 2 by 5. And if I have plus 2 by 5, my graph would just be inverted about the x-axis, right? So I have two solutions right here, and my log 5x would obviously pass through 1, right? But I don't know if it would pass like this or it would pass like this. So obviously one solution is here at 1 and another might be cutting again, right? So I just need to find the tangent f dash x. I just need to find the rate of increase of it. So f dash x, for obviously in this case you would have only one solution, right? Only one solution. For the second case, for this is for a is equal to minus 2 by 5. Only one solution, which is x is equal to 1. And for the second case, when a is equal to plus 2 by 5, I would have dash x would be a times x minus 1 power 4. Uh, 1 second. Fx, sorry, fx is a times x minus 1 power 5 plus a times x minus 1 power 4. This is still the case where a is equal to b, right? A is equal to b. So a, oh yeah, I just had it, right? I wrote it, my bad. So this was my fx, right? So f dash x would be a times x minus 1 power 4 plus 4ax times x minus 1 power 3. Obviously x is equal to 1 is one solution, and ax minus a plus 4ax equal to 0. So 5ax is equal to a. and x is equal to 1 by 5. So uh, x is equal to 1 by 5 gives me f dash x is equal to 0. Well, this was of no use, my bad. I just need to check about f dash x, right? So I have another function gx, which is log base 5x. I can write this as ln x upon um, one second. I can write this as, yeah, ln 5. I can write this like this. So this is 1 by ln 5, and then I can just differentiate it now easily. So g dash x would be 1 by ln 5, hence 1 by x. So I just need to compare both of these, and when you compare this, obviously this is a decreasing function and this is an increasing function, so the f dash x is basically a greater value. If you look at g dash 1, you would have 1 by ln 5, and for f dash 1 I have 0. F dash 1 is 0. This is a positive quantity, right? G dash 1 is greater than f dash 1, but g dash tends to 0 when x tends to infinity, and when x tends to infinity, f dash x tends to infinity. So this shows that if at some point g dash 1 is greater than f dash 1, okay, so if it's increasing at a rate greater than the rate of increase of f, then it means that it has to cut somewhere, right? So definitely I have one more cutting point, which would be somewhere here at some x such that x is greater than 1. Okay, so we have solved the next part as well. So so according to my solution would say that the number of solution is uh, there is how many solutions? One solution such that a is equal to minus 2 by 5, and two solutions if a is equal to plus 2 by 5, right? So according to that, my question should be, my answer should be, I have no idea, let me check once. The answer should be C. Yeah, 1 if a is equal to minus 2 by 5, right? Okay, let's come to the third part of the question. I'll just take this picture again. Yeah, so the third part of the question says if b is positive, so yeah, b is positive, then the maximum value of the function fx is equal to k times b by 5. Okay. So b was positive, then we had b by 5 power 5 times 4 by a power 4. Sorry, this was my f max. So k is definitely 4 power 4. And the last question asks you this thing. This is like a very easy question, and this is true for yeah, this is a very easy question. I can just use f of x, this property, King's rule, right? So I would have f of 7 minus x minus 5, right? I hope it's fine. X minus 2, yeah, and f of mod 7 minus x minus 2 plus f of mod 7 minus x minus 5. When you calculate this, you see that this is just the, if you add these both up, you would have 2i, and it would be just 1 and 0 to 7 dx, and you would just have 7 by 2 to be the value of the integral. So I think that was the last part. It was 7 by 2. Okay, So this question was a pretty good one. It took a lot of time to solve this. It took me 20 minutes to solve this question, and that too after I have done before. Whatever. So let's move on to the next questions, and I'll just be quick now, uh, because the other ones are just easy. It's from a mock paper. Let's move forward. Okay. So this is the question. Um, the distances from the origin of the center of the circles, this is this, and variable are in GP. Okay, so yeah, so x square plus y square minus 2 lambda I x is equal to c square, where x minus lambda I squared plus y squared is equal to c square plus lambda I squared, right? So radius is root c square plus lambda I square, and clearly this is, so the distance is just lambda I, right? So the lambda i's are in GP, okay, and it's so L1, L2, L3 are lengths of tangents drawn to these circles from any point on this circle, and what is always true. Okay, okay, so it's saying about any point about this circle, x square plus y square is equal to c square, right? Yeah. So I'll just take any parametric point c cos theta comma c sin theta, and let's just form tangents. This is lambda I comma 0. This is nothing. This is just a tangent. I would have 90 degrees lambda I, right? No, sorry, my bad. This is not lambda I. This is any general point c cos theta, c sin theta, and you have this to be the radius, which was root lambda I squared plus c squared, and this is the Li, right? So I need to find Li. Li can just be found by Pythagoras theorem, right? You don't have to use complex coordinate geometry for this. So lambda I minus c cos theta, right? C cos theta squared plus c sin theta squared minus lambda I squared minus c squared. This would be lambda I squared. Okay, so let me just do this directly. So this would be c squared plus lambda I squared plus, okay, minus 2c lambda I cos theta, and then you would have this cut, and this would be the length. So Li is equal to minus 2 lambda I c cos theta. So this was just the x coordinate of any random point on that circle. I would just write this as x1. Okay, so Li is equal to minus 2 lambda I x1. So clearly if lambda I is in GP, I would have Li in GP. So this was a pretty easy question. Uh, my answer to this would be, they are in geometrical progression. Okay, just a few more questions left. Two more. Last one is extremely easy too. The last questions are from a mains mock test, so yeah, they are easy. Okay, this question is fx is equal to 1 by x minus 2 by e power 2x minus 1 can be made continuous at x is equal to 0, defining f of 0 is equal to. So you just need to find the limit of x tending 0. That's it. Because yeah, that is what makes it continuous, right? So I have this. So limit x tending 0 fx is equal to. Now the problem is, what I did earlier was I did this, and this would become 1 by x and 1 by x, and I would just cancel and say it's 0, but this is wrong. Why is this wrong? It's because at the time when I cancel 2x and e power 2x minus 1, I had to make sure that both the limits exist, but they didn't, because there was 1 by x in the same equation and it did not exist when limit was x tending 0, right? So I cannot do that. However, it would be easier if I take this whole into a fraction and I just try to do the same thing I did. So this would be my solution now. I would just multiply this whole expression by 2x, and knowing that this thing would converge, right? Because this is just x, I can apply L'Hospital's rule and I would just be left with a limit that exists, right? So it would belong to R. So I can, oh my bad. Yeah. So this is 1 and I've been left with 2x. So e power 2x minus 1 minus 2x upon 2x squared, right? So this would be 2 e power 2x minus 2 upon 4x. So 2 times e power 2x minus 1 upon 2 times 2x. So this thing is 1 and yeah, this is 1. So the correct answer is f of 0 is equal to 1. Just take this as a subjective question, okay? I'm not gonna be giving you options on each question. Okay, the last question is pretty easy, and thank you for watching if you're still here, because this is a very easy question. So you just need basics of coordinate geometry on complex plane. Okay, so this is my circle. It's at minus 4. My bad. I should draw this like this: minus 4 mod z plus 4 less than equal to 3. So this would be minus 1 and this would be minus 7. So this region indicates this particular equation, right? Alright, so now that I've got my equation, it's asking me what is the maximum value of z plus 1. So what does this actually mean? This is just the distance of any z from minus 1, right? So any z belonging to, let's say, this set is called A, would satisfy this condition. So obviously, which point is farthest from here? This point, right? So this was a circle of radius 3 and this is 3. So the total distance max is equal to 6. That's it. So nothing else to do in this question. This is just 6. And that is it. Thank you for watching. This question was pretty good. I had 2, no, 4 C, B, and C. This is B, this is 1, and this is 6. So if you have attempted them yourself, that's the answers for you. Thank you so much for watching. We'll meet again, I guess.